Ah, there it is. Red light time. That's always a happy time because it means let's get going. Let's get talking about some interesting science, some real cool science. And as you know, A and P students, we are in the middle of learning about muscles and for the most part how they work. And that's some that's some pretty high level stuff. That's some pretty interesting stuff. And here we're going to continue with part two. In our first video, as you well know, we talked about how, and then now today we're going to talk about what the three types of muscle that we have: the skeletal, the cardiac, and the smooth. And so we're going to have a good time with that. But hey, welcome back. Hey, thank you for opening this up and for continuing your educational journey. And as always, I appreciate being a part of that journey. Man, love you guys. Appreciate you guys and everything that you're about and you got going on and just all the stories and the families and stuff. And it's just been a good semester. And but man, we are super close to the end. I mean, here we are. After I get done with this one, man, I only got one more to make because cellular respiration, which is our next unit, that's a bio topic that they've actually done a long time ago. So it'll be our last come back together with everybody in the room at the same time. No, but anyway, that's it. That's down the road, and then I've only got one more to make, as I mentioned, and that's the blood, and that's our last one, and that's so that'll be kind of bittersweet. It'll be good to have this heavy workload done, but it will be uh, the bitter part will be the fact that we're almost done. And once we watch that one, then it's just finals, and after that, so yeah, then it'll be done. So essentially, a month from now, it'll be that Sunday and going into finals, and we'll probably have ours. It's supposed to be the last day that you would have met, so it'll be on that Wednesday. But yours are going to be online, so just sometime that week you'll knock them out, and it'll have a Thursday deadline because I've got to turn grades in on that Friday. So you'll have a Sunday through Thursday to get all that stuff done, and who knows, maybe we'll open it up even earlier so people can knock them out over the weekend maybe, and we'll have to just see how that goes. So that should be my goal on during Thanksgiving break, maybe on that Friday when all the once I wake up from my turkey coma, because man, we already got plans for two, and I'm trying to talk her into a third one, and I don't know if I can get that. I don't think I have enough votes for that, but we're gonna find out. Yeah, we'll smoke one. Love to fry one. Never have done that. Love to do that, but we'll see how it goes. But certainly gonna smoke one, and we'll just see how it goes. All right. So hey, muscle fiber. Oh, but again, hey, thank you for being here again, and I hope everything's going well for you. And as we zoom towards Thanksgiving break, and as you know, as a Crowder student, once you get a Thanksgiving break, you're just about done. So here we go. Um, yeah, muscle fibers, smooth. So let's get this started. We're going to start with skeletal muscle, and as you can see, we'll talk about this. We've got a little bit. Oh, didn't do my usual. As I usually got my notes here, and as you can see by the clock down here, it's pre-lunch, so we're water today. And as soon as this one gets done, it'll be lunchtime. Got a good lunch plan today. We smoked some ribs on Saturday, and that's such a fun time because it was a nice day yesterday, Saturday. Lots of yard work. I got one more. I mowed again just to kind of clean everything up and leaves And we just spend a lot of the day outside, and man, when you're smoking ribs and you're outside working, man, it's a nice time, and you could smell that stuff for all over the place. So and the neighbors certainly know when we do that kind of stuff, because it diffuses out, that's for sure, to throw some science in there. But hey, yeah, I got a good lunch, got some leftovers of that, and that's the beauty of, well, I shouldn't say the beauty, because I love seeing my kids and the grandkids, but man, when you smoke a rack of ribs now, they last a few days. Back when the kids were here, especially Patrick, and but don't tell her I told you this, but Leah could eat as well, so she could hold her own there too. But man, once we smoked a rack of ribs in, it was all gone at dinner time. But now it lasts a couple of days, so that's the beauty of that part. So, but anyway, I'd certainly go back, not to the stage where a lot of you guys are at with the young ones, but I'd certainly go back to 8 or 10 and do that all over again pretty quickly. But enough about all that. So we are going to start with skeletal muscles. So let me get myself a little box, and just spoiler alert, we got quite a bit here. So just buckle down and check that pen. If it's low on ink, you might as well just set it down and get you a new one. And if it's you got a mechanical pencil, you better double check, make sure you got enough lead in there. And because we do got quite a bit just to get to this image. But once we get past the skeletal muscle, a lot of the heavy notes will be done. And mainly because the other two are kind of the same type, smooth muscle. And so a lot of the explanation is for both, and so that kind of double dips and cuts down on the amount. But we do have quite a bit right up front, so just spoiler alert, if you're tired and need a little nap, you might want to pause it now and go ahead and take that nap and then come back to it. But here we go, and we're also going to invoke, let me just show you this. I'm going to lose my box here, but that's all right. No, didn't mean to do that. That was not a strong teacher move right there. We are going to invoke the processes that we talked about last time, because in the talking about the how, now that we're going to do the what, we'll be mentioning this stuff, especially when we talk about the myofilaments, the thick and the thin, and the active sites and stuff, and we'll go down to the spots just to remind you of what we're talking about, just so you can have that mental connection. And so we will be doing that, because that's why I put all this stuff right down below here. So bring that box back up and let's get her started. I always want to put an E there. I don't know. I always have to check myself. I always want to put that third E there, but yeah, I don't know what I was pausing there for. Just double checking. Always got to double check that spelling. I mean, this whiteboard, this Microsoft Whiteboard app that I use to make these in, always keeps giving me these new updates. But man, the update I need is the red line underneath it when it ain't spelled right. That's the one I need there. All right, so the skeletal muscle, we're talking voluntary, which means you control it. Okay, you control it. Your leg needs to be picked up to move. You need to walk. You need to pick something up. Your brain gives the direct command to make that happen, and goes through all those processes. And once you get to ANP2, you'll learn those processes. That's the very first thing you do. The nervous tissue, spinal cord, brain, those first 3 chapters right off the bat. Okay, we're also talking striations. And when we talk in striations, these are alternating bands and we're gonna break this down to what's causing the lighter color, what's causing the darker color. But it's the myofilaments, that thick and thin, that we're going to get into. So we'll explain all that, and the Z bands and the A bands and all that stuff, as a way to understand how everything is working. And let's see, these bands. Let me go down here. Oh, you know what? I didn't do. Yeah, let me just do that. I'm not sure if I actually need it just yet, but we will right here. The bands, okay, overlapping internal contractile proteins. That's just a fancy way of describing the thick and thin myofilaments that we're gonna get into. And last thing, centimeters. And most of that length, as you could imagine, would come from leg muscles. I mean, that thigh muscle, hamstring and stuff, calf muscles. I mean, those are pretty long muscles, as opposed to in your back muscles as well. Almost forgot those. Things like that are certainly long. And any time that you have, and I'm going to space down here just for separation, and anytime you have tissue going on, you know the connective tissue is going to join the party. And there are some elements here of that, and so we'll talk about that right now. Certainly the tendons. Okay, and of course, as you know, that's muscle to bone. That's why we're talking about them, because we're talking about muscle. And there are 3 types of connective tissue. Endomyosin, okay, endomyosin is I'm going to do CT, connective tissue, just for time and space, but recognize that CT refers to connective tissue. Connective tissue that goes around the muscle cell, and then that should make sense. Endo, I'll draw a pause there, because I was going to say endo would be inside, but it's endo, yeah, because it's inside of, this is the, see if it's in here, over here somewhere. No, it's not. It's going to point it out. And then the perimyosin, this is CT. Around the muscle fascicles. Oh, I forgot my dash there. Hopefully you put yours there. And the epimyosin. This is CT surrounding around the entire muscle. All right, and next up, and in CT connective tissue. No, the A goes first. No, how about that. There we go. So what we're talking about here, you've got this connective tissue around the entire muscle. You've got connective tissue around the muscle cell. And then you've got, I put a space right there, which I did not need, around the muscle fascicles. And then once that, as it moves through and down and out to the edge of the muscle, it then leads into the collagen fibers of the tendon. And one more, of course, somewhat elastic, but we see enough tendon and ligament in the same way, see enough injuries that we know it's not completely elastic and does have a breaking point. And that is all for that section. And it is time to flip over the notepad. All right, so this next part, let me go down one more. We're going to title this Muscle Fiber Components. In other words, a big old long list of things that are within a muscle fiber. Starts off with the subclima. And this is, okay, right here, this elastic fiber around, just a big old protective sheath around the entire thing. You can see there. Yeah, it's the plasma membrane. Seeing if I wanted to capitalize that first word there, was that dramatic pause there. And MF, muscle fiber, just for time and space there. So in other words, if this is the plasma membrane of this entire muscle fiber, so all this stuff will be considered a muscle fiber. And if this is the plasma membrane, that means that that's what's going to diffuse, stuff's going to diffuse through. But it also means, hey, there's going to be decisions to be made. Does it come in? Does it not come in? And as we know, muscles are going to need a lot of stuff. Should have put me a line there. Okay, next up, the sarcoplasm. And this is the cytoplasm. And again, MF, muscle fiber, just for time and space. So if we see over here the sarcoplasm, it's going to be just this space between, okay, the plasma membrane and all of the components in here. And in that spot, I mean, you're just going to have things diffuse through, floating around, moving around to get to wherever they need to. But that's the sarcoplasm. And next up, the myofibrils. Okay, these are long protein bundles, and it's got glycogen. Okay, and hopefully you're familiar enough with glycogen. This class, we didn't go through the, well, we haven't gone through the cellular respiration stuff yet, but we will. But glycogen, as I'm sure you know, is just our way of storing the sugars that we receive from plants. I mean, when they photosynthesize and they make the glucose, and we receive it, we convert it and store it as glycogen. And when plants convert it to store it long term. They serve it. They store it as starch, but that's what glycogen is. And we also have where am I at? There we are. No, that's all I want to put there. Okay, next up, lots of mitochondria. And again, that shouldn't be a surprise. I mean, that's energy production. When we talk about cellular respiration, you'll see that. And of course, we're making ATP. And it'll be good for you to talk about cellular respiration. I mean, so much of the stuff we're talking about now, the muscle fibers, need energy. And plus, that's one of my favorite chapters. I tell the bio people all the time that chapter 6, 7, and 8 in their book, the energy unit, energy self. I mean, I love talking about that. So chapter 7 in their book, certainly one of my more favorite ones. Plus, it's just got a lot of cool stuff to talk about. Okay, next up. Sarcoplasm, reticulum. And I didn't put my line over here. Go back and catch that. Now, when we say reticulum, I mean, we talk about this kind of stuff and way back in the organelle, the cell components. These are places where stuff is made. If it's endoplasmic reticulum, then we're making the proteins. If it's, if it's rough endoplasmic reticulum, that's when we're making the proteins. If it's smooth endoplasmic reticulum, then we're thinking lipids. Okay, so we're thinking lipids. We're going to put that down here. But first, this is smooth endoplasmic reticulum, so we're thinking lipids. But we're also storing calcium. Okay, we talked a lot about calcium last time because that's what activates the muscle contractions, and that's what starts that process. The calcium sits down on those muscle fibers, and if you remember, it causes it to kind of turn to where the active sites are no longer blocked, and then those globular heads of the myosin can connect with those active sites and pass that stimulus along to make it contract. Remember, it just keeps kind of going up and back, up and back, up and back. Active site release to keep that twitch going. But again, when we talk about, we have a slide of that, and when we show those, we will bring that back just to remind yourself what's going on there. Next up, terminal cystin A. Okay, and this is just a collection of the sarcoplasm reticulum. So that SR, sarcoplasm reticulum, it's a collection of them. And when we have that, it runs the length of, see, is there one over here? Yeah, terminal cistern A right here. So let's follow that, arrows. Well, it's pointing to those blue things, but those are obviously blood vessels. That's pointing to. No, I'm sorry about that. I shouldn't have said blood vessels, even though it's blue. I hate it when they use common colors that are identified with one thing. But so it's, no, it's these two things here. They run along the muscle fibers, and they're going to kind of overlap and connect each one. But again, that's just a collection of the sarcoplasmic reticulum, where we're storing the calcium, we're making the lipids, that kind of stuff. And then the pink is what we're going to talk about next. Yeah, the T-tubules, the transverse tubules. And we saw these in, get my line in here. I better capitalize that. Okay, long tubes of the sarcolemma, which we talked about. Up here, the plasma membrane. Okay, so these, we're talking about these blue and what do you call that, pink or light purple. Okay, so they're running. Oh, there's Avery. So there's she's outside. There must be some kind of a venomous squirrel, or more likely when the neighbor cats are walking by, which is her routine every day. She sees those cats at least 10 times a day, and every day we get the same reaction. Don't come over here, and they never have come over across the street. So anyway, it's just the way, it just keeps her young, I guess. All right, back to, yeah, and again, running the length of across these muscle fibers here. So these blue and whatever it's called, that light pink or pink or light purple, that is up to you. Now the combination of these two is called a triad. And a triad just simply refers to T-tubule and 2 cisternase. And that's why you see this combination here. I mean, there's one T-tubule and 2, and so this section, there'd be one triad, here's another triad, here's another triad, like that right there. And let's see, and that is all for that section, and that is all for this section. So just to kind of review what we've already touched on. Of course, the sarcolemma, the plasma membrane, the sarcoplasm, the cytoplasm. Okay, the T-tubules are the transverse tubules, and when we talked about those last time, let's and we can do that again. Let's bring this down and let's slide down here and find all right, there's a T-tubule right there. So that when that calcium exit, if you remember, opens up that calcium channel and just allows it to flow through. Here you can see it passing through, and the calcium then diffuses out to all the other stuff. And you can see here's our topic right here that we're going to talk about here shortly. But let's go up here, and we've done this. So now we're going to be right here. So we'll open up a box here. And essentially what we're going to do now is just go down this direction to all these diagrams and just say a little bit about each one with note, just kind of like what we did last time. And when we get to the end, we'll be done. We're 29 minutes in, as you can see. And we are, as far as note-wise, possibly halfway through already, so we'll see how it goes. But this is myosin. And you can see here, just a breakdown of, and we'll type this, but we'll talk about it first. This is that globular head. This is the globular head that is eventually going to connect with these active sites. That we talked about this last week, but we'll showcase it again. And this is the thick filament, and these just wrap around these thick filaments and these globular heads. And then this is the thin over here, but we'll talk about it. And these just kind of overlap, and when it's time to contract the muscle, the stimulus comes through. The globular heads kind of raise up and connect with those active sites that are right now underneath these tropomyosins. But then they rotate slightly just to get uncovered, and then that allows that active site to be, and then you can see there's a whole bunch of them, and there's going to be a whole bunch of active sites, so they'll all just kind of connect with each other to keep that stimulus going. Okay, but first off, and you can see, and this is kind of a limiting reference, because you may not have any, not club, how about club? And what I mean by that, kind of like a driver. You got that long shaft, long thin shaft, and then that kind of that big block head is what we're referring to there. But if you don't have a reference to golf, then maybe that won't mean anything to you. We've got the and we've already said this, but we will now type it as part of the muscle activation. And yeah. All right, so that is that part. And again, let's bring down the stuff from last week, and let's find, yeah, there it is right there. Slide this over just a little bit more. So you can see what we got going on here is this is that myosin that's wrapped around the thick filament, and then these are the thins here that we're getting ready to talk about. But you can see that when the ATP comes in, we break off, the cells separate one of the phosphates, which releases energy, and that energy allows that globular head to kind of get into position. Okay, the thin myofilaments kind of rotate slightly. You can see that here, which is a picture we're going to look at, the active sites are covered, but when they rotate slightly, both above and below, now they're open and access, and obviously the thick filament down below would connect with these active sites, and then the thick myofilaments above would connect with these active sites, getting that stimulus moved along. And of course, we talked about that one of these can get 4 or 5 twitches in, and let's see if we have that. No, but anyway, that's the idea of how that works. So let's go back down here where we were, and now we'll be right here with the thin filament. Well, you're getting your lots of every talk today. If you can hear that or not, maybe you can't. The distant bark in the background. Let's see, the thin myofilaments. Two strands, and we're talking about these two right here, 2 strands globular actin, and of course with those active sites that in this scenario are covered, but again, when it rotates, as we've said a couple of times, they become open and usable. Let's see, now we're going to space in just a bit just to reference that this is under what we've already got. You know what? No, we're not going to do that. You can just set right there. And we got the tropomyosin. Another O there. Yeah. And so we're talking about these bluish white bands here. They cover the active sites, and the obvious reason for that is, I mean, when the muscles don't need to fire, I mean, you don't want just incidental stimulus, so they get covered up until they're ready, and so they get so that calcium arrives, and they get a sense of, hey, we need to respond to that. So it's kind of a feedback mechanism. And then we have the tropopin. And so now we're talking about this process, or this item, is not even the right word, this thing right here. And that's where the calcium binds that we saw last week. So if we go back up here, and yeah. Okay, so here's the tropopin, and that's where the calcium comes in and binds, and then that spins or rotates the thin filaments and allows the myosin to connect with the active sites. And the last thing we'll say here, so let's edit this, is so as you can see here, and again, I am dropping the ball on my strong teacher moves today. I guess I'm thinking about those ribs too much that I'm about to have. So the thick and thin myofilaments work together not the W, there we go, activate the muscle. And that's the last part on that. Okay, this next part we're going to talk about is we're going to talk about the striations, okay, and what gives it that unique look. And you can see, I mean, this obviously is a computer generated model, but when you see an x-ray of the actual the way it looks, I mean that's super highly organized. And of course, you can see now what's called the light and dark sections, the I bands, the A bands. You've got that M line going through there. And what you don't see here is you don't see the Z's. No, there it is right there. And so, and those are anchor points there for these different filaments here, but we'll talk about all that. And the sarcomere, the covering, and how that works, how that kind of scrunches down and relaxes. That's what creates that contraction in the individual myofibrils. You can see those kind of sections. So like that would be a band, that would be a band, another band there. And you can kind of see the little bit of the separation there, a little bit there, and certainly there as well. So we'll talk about all these different kind of bands and discs here, and then we'll reference the sacromere over here, and that'll just about wrap up skeletal muscle. So let's start here. Give me a little box. In striation, so we're going to break down each of the parts, the components of what makes a striation. Okay, so we mentioned the dark and light earlier, and we can kind of see here why it's named. So what you would have then, of course, then that means this is another A band with the M line, and this would be another A band over here. And it's just alternating, so then there would be a light, dark, and back and forth. And so earlier, when we looked at way over here, skeletal muscle, those alternating bands of transverse bands, this is what we're talking about. All right, so we're going to start with the A's. Okay, the A bands. These are obviously your dark. And this is the section of the muscle where you're going to have both filaments. Okay, so you're going to have both, which gives it that dark look. Because it's thick. In other words, light doesn't get through. It's just thick stuff. Okay, that's the A bands. Okay, now the H bands, and you're going to see them. They're right in here, very small. See, the A bands are pretty wide, the I bands are pretty wide, but the H bands is a section only thick, and you can see that if we look at, so like here's an A, okay, and then here would be an A, and that H band. So what you're seeing is like this section here is this section here. Let me get a pen. That'd be a better way of doing it. Let's see, red muscles. Let's use the red pen. So like this section right here is going to be this section, and then this section is going to be this section, and in this part here in the middle, where there's only thick filaments, it's going to be this section. So, contains only the thick, and of course, then you got that M line that's going right down through there. All right, so we'll edit that. Keep going. Okay, next up, the M line. And we just think of that as the median. The M stands for median, not an M. Okay, you can refer to middle, something along those lines. All right, now the I bands. This has thin filaments, so it has the thin, okay, and elastic filaments. Okay, and you can see that's the green in here. So that elastic aspect, as it stretches and then contracts back, goes back and forth, gives it that elasticity, and then to do that, to stretch and then come back. And that is going to be this lighter section over here. And because now you've only got one of the more dense filaments, and in a very kind of opaque coloring, that's the I bands here. And of course, then this line here is going to be the Z disc, And is that next? Yes, it is. Okay, the Z disc, those are anchor points. Okay, those are anchor points for I bands, connecting one to the other. Got that zigzag fashion, which corresponds with kind of their alternating, because even though it's connecting, they're not directly across from each other, they're alternating. And what happens when it comes time to stretch or contract, that Z disc kind of extends, okay, and kind of pulls everything and relaxes to release the tension as well. And then the last thing to say about this, and we're going to talk more about it at the next slide, but the sacromere, we're going to mention it here, but then we'll tell about what it is. But it's just a need a second S in there. A tissue covering from Z to Z. So in other words, the sacromere is going to cover all of this section right there, and of course, then from this Z to the next Z would be another sacromere, and the same thing going this way. But we'll talk more about what the sacromere is next. So we are done right there. And let's get us a text box here, and I'll just go underneath those arrows, which will probably end up being pretty confusing because I shouldn't have crossed. But again, this section is this section is this section, and that middle, which obviously is blown up so you can see it, is that part in there. All right, so, and this is just one note here. I'm not even going to give you a outline format. So when the muscle does contract, is the sacromere all the components. Nope, just one. So that sacromere, when it contracts, I mean, it just kind of squeezes everything, and then when it relaxes, everything expands back out. Oh, that was a hard freeze right there. So hopefully we are not offline as far as what the mouth is moving, the words that are coming out. But since I just record these, and I don't want to actually watch them, it may happen, and you'll know more about this than I would. It may happen quite often. That's one of the Christmas plans, is the serious upgrade on the computer, because I know that at times when I go back to watch a part one to kind of see where it ends, to remind myself of where I got to pick up, it's off. And so you would probably tell me that, yeah, it happens every time, and there isn't a smooth ending. But anyway, it is what it is. At least you can hear the words and make fun of the fact that the words in the mouth are not matched up. So, all right, so sliding down. Okay, so that ends the talk on skeletal muscles, and now we're going to start to look at cardiac. Let me move this down to get it out from up there, and then move this back up to get that off the screen. So now we're going to talk about cardiac muscle, and this is a part of the smooth muscle. So we're going to talk about cardiac and its notes, and then we'll go into the smooth muscle. So I'm going to put cardiac here, smooth here, and then we'll talk about the diagrams. And so at 50 minutes, we're about 75% done. So yeah, skeletal muscle is a big part of, of that, as I mentioned earlier. So cardiac muscle, it's got lots of needs. So we're going to do needs, and then we're going to do characteristics. So needs. I didn't do a mic check. You never see it, but I usually check to make sure the mic is working fine, and I didn't do that. So I guess I'm hoping that it is, but I've always checked it, and it's always been. So I guess that's why I got complacent, which is a huge word, and that's a great teacher move right there. But the needs of the cardiac muscle. Hey, it's got to contract. With a regular rhythm. And I don't look right. Oh, I left out my H. And yeah, and that's the understatement of the year right there. It's got to contract with a regular rhythm. I mean, and there's all kinds of conditions when that is not happening, and all kind of adjustments can be made, including a pacemaker or other medicinal prescriptions to kind of help out with that. And let's see, the muscle cells. Okay, unison, yeah, that's right. They've got to contract in unison. And so in other words, you can't have a delay between the first ones, okay, and then passing through. I mean, it's got to be at the same time. It's got to squeeze like you were squeezing a tennis ball or a stress ball. It's got to squeeze together. It can't be squeezed. It can't be squeezed like that. It's got to be like this. So, but again, that's an understatement of the year right there. Okay, and the contraction. Must be long enough to push the blood through. And when we talk about smooth muscle and how they work, one of the things that we're going to emphasize that most smooth muscle, okay, which cardiac muscle is smooth muscle, is really just trying to push something through. So when you think about the lungs and the heart and the digestive system, bladder, that kind of stuff, I mean, they're trying to just push something through. And so therefore that's got to be long enough to get that done. And it must be highly resistant to fatigue. And because we know that it is, I mean, the heart muscle, it doesn't ever get tired, so it must somehow be different structurally in the stimulus. Must be different than the leg muscle, because we know the leg muscle can get tired. I mean, just walking. Of course, a lot of that is, the weight that they're carrying and the fact that they're doing work. But again, so is the heart muscle. Okay, and so the cardiac muscle has characteristics. And it starts with, it is styrated. You can tell it's a nice day out there because the dogs are outside a bunch, and and the squirrels are out running around, the cats are out running around, so there's all kinds of things for them to get fired up about. So yeah, hope you're enjoying the dog barks. All right, each cell Oh, wait, no, this is a whole different one. Sorry if you've already started writing, but this actually goes down here. And this is part of that, what makes it resistant to fatigue and helps it to be more efficiently getting that signal across at a quicker rate to make sure that all the cells work. It's that intercalculated disc. That's just a much more efficient manner to communicate and to move stimuluses along than the skeletal muscles, which are still super, super quick. We know that. But this is even more efficient, more speedy, if that's an actual word. Well, it is a word. I don't know if it fits right here, but it's the one we're going with. And I said all that, and let's make sure we also type it. Efficient. Between cells. And when we say communication, we're talking about moving that stimulus along, moving that communication along in a much more efficient manner, both with speed and fatigue resistance. Okay, those intercalculated discs also helps tearing apart. In skeletal muscles, injury and stress can happen all the time. These intercalculated discs help to reduce that to where, if you just think how much your muscle, that heart muscle, boom, 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 keeps going. It can't just have constant repair. It can have constant repairs, and it does, but it needs to limit as much as possible that fact, and the intercalculated disc is what helps with that. And of course, we've got our T-tubules, as we've referenced a couple of times now. Okay, but in this case, they're larger. And if they're larger, it allows for greater calcium intake. Yeah. And that way, when those signals come through, you can have more calcium in there. And again, that's just going to speed up the process of getting that signal across. And so that way they all can work at the same time in a much more efficient manner. And two more. And this is a huge deal. And I loved in A&P2 talking about this process, but it contains its own pacemaker. And that's huge, because what that means is that not only is it involuntary, but it's ultra involuntary, because involuntary by definition means that your brain takes care of it and you don't have to focus on it, think about it. You don't have to say heartbeat, heartbeat. In a typical involuntary, like with your kidney, okay, the brain just takes care of it. The endocrine system and the brain and everything just takes care of everything and does it kind of in the background. And you don't have to deliberately think, okay, filter toxins, filter toxins, filter toxins. No, the brain takes care of that. But in the case with the cardiac muscle, it doesn't even have that process in place. It has its own system built in that makes that pulse beat And so even the brain doesn't have to handle that and send constantly streams of endocrine hormones to make that beat. It's got its own internal system in place. So we're ultra involuntary. Now it's completely just works on its own. I mean, it works on its own. Doesn't have to rely on anything else. Uh, and so that's why essentially a person can be. No, I better not say that because I might not actually be right. I was going to do a little metaphor, but that may not turn out to be true. So I will withdraw my previous statement there. And where are we at? Oh, and of course, another obvious statement. Needs lots of oxygen, and not just to pump it through to the blood, but itself. I mean, if you're going to work that much, that hard, that long, that consistent, that often, you're going to need lots of oxygen to keep that energy stuff going. Okay, so that is it on cardiac muscle. So we will close that, and we will open up a new text box, and we'll put this one over here, and we'll just have to line it up so we're inside of that, and then if we may end up having to move that, we'll just see. There's a couple of long ones. Actually, the longer ones are underneath these, so we're actually going to be okay. Am I really? Yeah, we're well over 80% done now. So, but at an hour or two, you would hope, huh? All right. So now we're at smooth muscle. In smooth muscle, these cells are long, fusiform shape. And fusiform shape, you can see them here. But if you want to think dolphins, or rockets, torpedoes, submarines, those are fusiform, long and then tapered at the ends. And fusiform shape as far as animals that have to move through mediums like water or air, like birds are fusiform. I mean, they've got the beak, and then they taper, and then they expand out to the head and the body, and then taper down to the tails. Dolphins, the nose, and then taper out to the body, and then down to the tail. Those fusiforms, which is, makes it more efficient moving through. That's why rockets and planes are fusiform shape, because it allows a more efficient manner. I mean, when you see, like when you watch sci-fi movies, which we do a bunch around here, and it's Sunday night, so I'm sure we'll watch one tonight while we're eating some dinner. Sci-fi movies, especially like the Marvel stuff, or when there's space travel, we're Star Wars people, Marvel people, and I'm leaving one out. But anyway, when you see some of the ships, and we're going to the Mandalorian right now, big time. When you see some of those ships, and they're just like big old blocky things, you're thinking, okay, that's not a very efficient. Like if you're a Marvel person, and here I'm trying to tell a story. I just lost my word. Okay, never mind then. But the Kree, the warriors, when they bring their ships, it's the same ships that Thanos brings out, and both Infinity Wars and Endgame. I mean, there's these huge long rectangles, and you're thinking, okay, that's not a very efficient way to fly through the outer space, especially at the speeds that they're going. But anyway, it is what it is. So the ship that Captain Marvel pushes to take those guys to their new home, they'll try to find a home. Big old blocky things like, okay, whatever. Not fusiform. That's a long way to emphasize that. All right, so back to where we were. Long fusiform, no striations. Okay, no striations. It does has the thick and thin. Okay. But not overlapping, kind of with the H bands. The H bands that we saw earlier. And all right, so let's just stop and move this picture over a little bit here. And back inside of here. But not overlapping. Okay, next up. Okay, no Z disc. Okay, so no D disc exists. So that would insinuate that the I bands, see, did I mention that? No. No I band, I shouldn't say it doesn't, no I bands, but they're attached in a different manner than striated muscle. Cytoskeleton, and we're going to see that instead of in the skeletal muscle, we didn't see any cytoskeleton. We saw cytoplasm, and that's because it's an area that needs that all the things that the muscle needs, the resources and things, has a place to float in once it gets through the plasma membrane. But the cytoskeleton that we're going to see is part of that contraction process, and we're going to see how that works. And we know cytoskeleton and its ability to contract or to kind of pull, because we saw that when we did the organelles. It's the microfilaments that are part of the cytoskeleton that are the ones that drag the chromosomes to the metal, and then they anchor themselves with the centromere on the edge, and then they pull those chromosomes apart, and a section goes to each end before the cell divides. Okay, and our last one, no T-tubules. Okay, so again, that means the calcium has to arrive in a different manner, and we will see that. Okay, and that ends that part, and so now we will move this up and over, and we'll bring this one down as well. Okay, so I'm going to type here in between for, no, I won't do it that, so let's move this over here. So there are two types. Let's do this with a pen. I haven't used a pen much today. So there are two types. That just brings back memories. During the coronavirus crush last spring, when I first started doing this, and I really had no idea what I was doing. I just know that from a high school standpoint and from the college class that we had to do something. I mean, went to spring break and came back, and we were shutting down. And of course, the world was just, panic in the street, as you remember. Most of what I did is I just wrote it out like this, and I realized, okay, that's not too efficient, because for one, it's not always legible, and it just looks kind of goofy. But there are two types of smooth muscle. Okay, multi-unit and single unit. And we're going to talk about both. So let's close that. And text box, bring her down here. We'll do multi first, and then we'll do single. And we'll just about be done. Really only got three things left to tell you. So, but a multi-unit, okay, and you can see lots of difference. When we say multi-unit, really, because we're saying that it's all one big connected unit, and in single, there's a little more separation between each muscle cell. But again, that long fusiform shape, and you can also see a difference in how they communicate. So here we go, multi-unit. You're going to find this in air passages, hair follicles, and one more, the iris. Iris of the eye. Okay, so just a few places. And so that means by default that the single unit smooth muscle is everywhere else. And we're going to put, most common, we'll type it over there. But it's just everywhere else. And so you want to, and again, you want to think all those passages, the bronchioles and the lungs and the digestive system and the bladder process and the heart, those are all single unit smooth muscles. Kidneys and liver and pancreas and all those things. And again, it's designed, most of them, just to push something through. But we will type that once we get to the single units. And autonomic, nerve fiber, NF, nerve fiber, and you can see that right here. And we'll talk about what that means. And here we go. Each all together. Okay, so the signal, I pointed the screen, just hit, I went like this, well, I know you can't see it. But anyway, so you got this signal coming in and it fires all at once. Okay, everybody gets it at one time, whereas the single unit, and again, we'll type this when we get there, the signal comes in and then a cell gets it, and the next cell gets it, and the next cell gets it. They can communicate that to each other or send that along to each other through these gap junctions here. But you don't see gap junctions here. They each individually get the signal, boom, all at the same time. And of course, the synapse we referred to in the last one, that's where it's going to connect with the muscle cell itself. Okay, so that is it for multi. So let's slide over here, text box. And let's move it down just a hair there. Okay, so the single unit, and I should have put that SM over there, smooth muscle. Okay. Everywhere else. And so over here we listed 3 places where the multi-unit, the smooth muscle is everywhere else, and then so by definition it's the most common, and it's also referred to as visceral. So you'll see that in the textbook. And when you start talking the organ systems in A&P2, you'll see that word visceral a lot. And so when you see that word visceral, it's referring to a single unit smooth muscle, which has more to do with how the stimulus is communicated than actual anything else. And gap junctions. Okay. when the cardiac muscle had those intercalculated discs to pass the information along and to communicate with each other, here we have gap junctions. And gap junctions we saw, let me make sure that my memory is right, that you guys saw that. But that should have been in chapter 4, the components of the cell. It's a way that the cells connect to each other. It's, if you think back to that slide, it's like brads on jeans. It's those little rivet points or metal points that connect or keep, hold things together, and then that allows the process. It's that same idea. Oh, I know you had this because we had a discussion in class one day, and I used the metaphor of an open window and that information passing back and forth. And I remember someone saying, "Oh yeah, I do remember that." So that's the gap junction idea there. And then lastly, okay, one cell signals the cells next to it. So they just pass the information along through the gap junctions until everybody has the message. But again, super quick, not as super quick and as efficient as the intercalculated disc, the cardiac muscle, but certainly smooth enough or quick enough to get the job done, as we know. I'm flipping the notebook over one last time, in a minute 16, an hour 16 in. So just one more little thing about this. Okay, we talked about the cardiac muscle, and I'm going to start this by saying smooth, SM, smooth muscle. Cardiac muscle is not only involuntary, but it deals with itself, its own. I mean, it's the one who signals to go, go, go. But smooth muscle is stimulated by the endocrine system. So we were talking chemicals and hormones, ions, like calcium, for example, would fit in there. But also hormones to say, hey, we got to get this done. Let's see. So the calcium enters. Myofilaments slide past each other. And, oh, not there. And then the thing that I've said a couple of times, the contraction. Push something along. And again, as I mentioned, digestive system, heart, lungs, bladder, all that kind of stuff. And even, oh yeah, well, I guess when it comes to childbirth as well, those contractions, the ultimate trying to push something along. So there you go, muscle fiber, part 2, okay, in the books, hour 19. Yeah, a long one, I know, and so was the other one. It probably could have been 3, but I don't know, they didn't do it that way. Mostly because I think we're ready to get these done and to get moving on. Not to move the class to be done, but making these videos. All right, but anyway, hey, thank you for doing this. And again, as always, and I hope you're in a good spot. The holidays are coming up, and I know a lot of you are not only students and workers somewhere full time, you're also moms, and that's its own job, that's its own full time gig. And so, hey, I just hope you're in a good spot. Hope you are taking care of yourself the best you can, and all the things that you've got going on, other than just this class. I mean, this class sometimes is like the 10th most important thing you're doing, even though it's long term huge. But you got a lot going on, and I know I was there once, but when you're there once and you're the male, it's not exactly the same as the female. I mean, there's more emphasis on making sure maybe the money is there, mentally as far as that. But just when you're the mom, it's just different, and it is, and unfortunately, not a lot we can do about that. It's just the way we're made, mentally, emotionally, that kind of stuff. So, but again, hope you're taking care of yourself. Hopefully, you find yourself in a good spot each day, and everything's going well, and you're well, your family's well, and everybody's in a good shape. So with that, we will close this out, and we will say goodbye until next time. The next time we'll be talking about cellular respiration, and those are already made. So once I get this loaded, I'll put those up. But again, it wouldn't be after Thanksgiving because, I gotta check next week. Not obviously this week, but next week maybe a test week. We'll have to take a look at that. And but anyway, enjoy yourself, and until next time, we will say goodbye.